Okay, so in this unit, we're going to be starting to learn how to use microcontrollers in MicroPython. A microcontroller is just a tiny computer that you can program and have it do different things for you. Typically with a microcontroller, you're going to have it connected to different sensors and actuators or lights that then are able to control those outputs given particular inputs. That is, let's say that a user pushes a button, it will read that as an input, and then based off of your code, it will tell the microcontroller to do something as an output. So maybe turn on a light so that every time you're pushing a button, it turns the light on. You push a button, it turns the light off. Normally, you would have a switch. If you were thinking about a light in your house, you give electricity to the light and it turns it on. But in this case, it's detecting a button press and it's doing a particular output. So instead of just turning the light on, you could have it flash the light. So you push the button and it flashes the light. That's something you can't do with just a switch, being able to control a light. So it gives you the ability to do things that otherwise it would be very difficult to do. And the way that you tell a microcontroller what to do is with code. And we're going to be using MicroPython to control a microcontroller called a Pi Pico W. And the Pi Pico W, you can see here, this is a Pi Pico. The Pico W has this extra chip right here, which is going to be the wireless chip. And the W just stands for wireless. It means that it can connect to the internet, so then you can have your code listening to a particular website so that you can send it commands remotely and it will do things for you. Ultimately, we're going to see how to build a Telegram bot, and you're going to be able to control your microcontroller by sending commands via Telegram. So we're going to be using this website here called Wokwi, and Wokwi is a really cool website. It's an emulator site so that you can emulate having a Pi Pico or Pi Pico W and running code on it from a browser window. And what's so great about that is that you don't have to have the hardware in front of you to develop. So you can go home, you can work on just in a browser, developing a project, developing code, test it out, see if it works. And then once you're confident that you've got it working, then you can actually load it onto a hardware device and test it out. So first thing you're going to do is you're going to go to wokwi.com and you're going to sign in if you haven't signed in already. And whenever you sign in, you're going to use a Google sign in and use your school Google address, Gmail address, and that will be able to get you signed in. And you can use this website, Wokwi, without signing in. It works perfectly fine, but you can't save your code or your designs. So being able to sign in will give you the ability to save your code. So once you get signed in, you should come up to this home page here. You're going to click on Pi Pico. You can see some featured projects. And if you scroll down, there's some starter templates. And you can see a Pi Pico, Pico W, and then MicroPython. So the programming language we're going to be using is MicroPython. They've got a Pico W here, which is the hardware that we'll be using, but this is using the Arduino programming language. And instead, we want to focus on MicroPython. We can handle using just MicroPython on the Pico instead of the Pico W because we're not going to do an internet project right now, so we don't need the wireless, so we're going to choose MicroPython. Whenever you come in, you've got your screen divided into two sections vertically. On the left is where you write your code. On the right is where you can simulate your code with your device, and you can also connect a bunch of different devices over here, which we'll look at a little bit later. So the first thing I want you to see is that on our code side, we've got an import statement. And an import statement is how you bring in tools into MicroPython so that you can use them. Now, MicroPython is very much like Python. It's just, and Python's a programming language that's very popular, but MicroPython is the version of Python that was developed for microcontrollers. Microcontrollers are not very powerful, so they needed a scaled down version of Python so that it could run on these microcontrollers. But in the similar way to Python, we need to import some different tools, some libraries that give us the ability to then use those libraries or modules for our code. So you can see that we're importing time, and then we're doing a time.sleep, and sleep means telling the microcontroller to wait, and here we can put in the number of seconds we want it to wait before it continues on with the code. and it's saying wait for 1/10 of a second. The reason that it's doing that is it's got to wait for the USB connection that it's emulating or simulating to actually connect so that you can see the output down here of this print statement. And this print statement says, hello Pi Pico, and we should see that output pop up in the bottom of the screen. So I'm going to click Start the Simulation. You can do the same, and you can see that there's going to be a black window that appears at the bottom of the screen, and this is the simulation running. This window right here with these 3 greater than signs are called, this is called the REPL. It's capital R, capital E, capital P, capital L, REPL. And that stands for read, evaluate, print, and loop. And the REPL is a way for you to actually run code a line at a time, or you can actually type out multiple lines and run them all at once, and have it testing out code that's running on this Pi Pico that's being emulated right here. So we're actually running the MicroPython on this board. It's not running on your computer, it's running off of this board, which means that as I type things, I can turn on this LED or do different things with the connections, line by line, testing out to see if the code works. So we're going to start in the REPL, see how the REPL works, and then we're going to move over here to this code window. So we're going to do a couple of things. One, I'm going to teach you how to use the print statement. We're going to talk about how to use the print statement, getting started in the REPL. Second thing is, over here in the REPL, I'm going to show you how to flash this LED light that you can see right there. And then once we've done that, we're going to move over here and we're going to type out our code, and you're going to see the advantages of using this code window, which is an IDE, Integrated Development Environment, and it's got some handy features that you'll see here in a second. So let's get started. So the first thing we're going to do is we're going to type print and an open parentheses. Now, the first thing you need to know when writing code for the first time, if you've never written code before, is that computers are not very smart. They're very fast, they're very accurate, but they're not very intelligent. So your computer, this code, this Python interpreter, has no idea if you were to use a capital P to write print that you want a print statement. It sees a capital P and it's like, I have no idea what that stands for. This print statement is all lowercase letters, so if you were to do a capital P print, it would not think that you're trying to print. It would say, I don't know what you're trying to do. So uppercase and lowercase letters matter when you're writing code, and you need to learn whether it's an uppercase or a lowercase letter. Now, our print statement prints a string, and in Python or in MicroPython, the way that we create a string is it's inside of quotation marks. So we're going to write hello world. This is the typical statement that anytime anybody's learning a new programming language, they always have you write hello world. It's just a tradition. We're going to have our closing quotation marks, and we're going to have our closing parentheses. So notice that we've got lowercase print, open parentheses, quotation marks, hello world, closing quotation marks, closing parentheses. And once I do that, I can hit enter or return, and it prints hello world. Very, very simple. Now, there are a couple things that you can do to make typing that in again easier, and I'm going to teach you a couple of shortcuts. One is the last thing that you wrote, if you just push the up arrow, it'll bring it up again. And then I can hit return, and it will print hello world again. So I'm going to show you what happens if I was to make a mistake. Let's go back to that capital P print, and let's see if it does anything. All right, it gives us a helpful error here. It says traceback, most recent call, file, standard in, line 1. Over here, this is less useful, but here's the key line right here, name error. It tells us there's an error with a name, and then it gives us the name. Print isn't defined. Like I said, it doesn't know what print is. It says it's not defined. So let's try another mistake. Let's not close our parentheses and see what happens. Well, it still thinks that I'm writing code until I close the parentheses, and then it finally will let me close it. Let's try another one. Let's not put that in closing quotation marks. It says invalid syntax. It means you can't have an opening quotation marks and not have a closing quotation marks. Let's try another one. Let's not do any quotation marks whatsoever and see what happens. Again, invalid syntax because I have a space in there. So let's just write the word hello and let's see what happens there. It says name print isn't defined. I went back to my capital P print. That was a problem. Now it says name hello isn't defined. That's because it thinks the word hello, when I put a word in here that's not in quotation marks, it thinks that's a special word called a variable. And a variable is just a box. It's a box you can put something into. And that box turns into whatever the object is that you put into that box. I'll give you an example. I'm going to just type a string here called hello. And if I hit enter, we can see it's a string because it has quotation marks around it. Okay? I'm going to type a number 1 and I'm going to hit enter. And it comes back with a number 1. Integers or ints or even decimals, which we call floats, don't have quotation marks around them. Only strings do. So I'm going to show you how to create a variable and to put that object, whether it's an integer or a string, into that box, that variable. So first thing I'm going to do is there's a special command in Python called type. And type, oh, by the way, it does not matter whether you do a single quote or double quotes. They're all the same in Python. So I'm going to go back to that word hello, and I'm going to have it tell me what is the type of hello. And it tells me the type is an str, a string. Remember I was telling you that anything in quotation marks is a string. Let's use that type again, and let's put a number 1 in. Remember I told you a number is an integer. And it tells us the class is an int, an integer. Let's do one more, and let's put a decimal in there. And it tells us that type is a float. And a float just means a decimal. It's a floating number, okay? So now that you've seen that whenever I put anything in quotation marks, it becomes a string, a number is an integer, and a decimal is a float, let's try putting those into a variable and see what happens. So the way that I create a variable is I just type some word. It can be made up letters, it can be anything. Can't start with a number. Okay, so I can't say a number. So let's just do the letter A. We're going to do a space. You don't have to have the space, but I think it's easier to read. And equals, just a single equal marks. And now we can put something in that box called A. So let's put hello in that box. And I'm going to hit enter, and nothing's going to happen because I didn't tell anything to happen. But now when I type the letter A, it's the same as typing hello. And notice, just like up here when I typed hello, it gave me single quotes hello. Remember, single quotes and double quotes are the same. So it makes no difference that it showed a single quotes here. It's just showing some quotes, which helps you to know it's a string. So watch this. If I do type A, it's a string. Now, I'm going to reuse that box, and this time there was a string in that box, in that variable. Now I'm going to put a number in that box and hit enter. Remember, nothing happens because I just put it in the box. Now I'm going to type A. What do you think is going to happen? It's going to show me the number 1. What do you think the type is now of A? A, that box became an integer because I put an integer in that box. The variable takes whatever it is that you assign to it, and it becomes that type. Now, Python or MicroPython is different from a lot of programming language in that it's called a dynamic typed language, meaning that I can be putting different things into the variable that was already in this case, the A was already a string. If I put an integer into it, it becomes an integer. And not every programming language is like that. So that's one of the nice things about Python that makes it easier is you don't have to track what type each variable is. It can become different types. All right, so I'm just going to go back to my hello world example and put hello world inside of my my A variable. And now watch this. I can print A. When I click print, or when I type print A, it sees that exactly the same as what we did originally, which was printing hello world. So we did print hello world and it printed hello world. So that right there is exactly the same, and it does hello world for me. Now, don't get confused. When you use a print statement, it doesn't put it in quotes. It takes a string and then it outputs the result on the screen. It's not outputting a string, it's outputting text. So it's just giving you the output. If I type A again, it'll put it in quotes because A is a string. All right, so that gets you some information, some basic information on types with strings, integers, and floats in Python. Now what we're going to do is I'm going to import some libraries. Excuse me. And we're going to try to see if we can get this LED to flash or to turn on. All right, so the way we're going to do this is I need to use an import statement. Like I told you earlier, we use these import statements in order to bring in tools that we can use in the programming language. Things that it has baked in but aren't already there so that our program stays small. Because the more things we import, the more code we're including in our program. So I'm going to do from machine. Now machine is a library. And in the machine library, there's a bunch of different tools that I can use. And one of them is called pen. And if you see here on this board, this pen that has a number 1 beside it is actually pen number 0. And I realize that's confusing, but it's GP0. So we're going to use, this is pen 0, this is pen 1, this is a ground connection. There are a bunch of ground connections on this board, and all of those grounds are all connected together. There's no difference between this ground and this ground and this ground right here. And you can know it's a ground because it's G and D. But there is a difference on these output or input pins, which are GP stands for general purpose, and it means you can use it as an input, you can use it as an output, you can use it for a bunch of different things that we're going to learn about. So we're doing from machine import pin, and as soon as I import the pin module, then that gives me the ability to be able to use these pins. So I'm going to hit enter. All right, now I need to take the output from creating a pin and put it into a box, that is, put it into a variable. And I can remember, we can make our variables be called A, we can make them be a bunch of letters, we just can't have it start with a number. I'm going to have it be LED, okay? It could be LED1, LED1, LED, capital all caps LED. One of the standards for Python that they recommend, you don't have to do it, you can break this rule, but I highly recommend that you follow it, is always have all of your variables be lowercase names. We usually save uppercase for special things such as classes or global variables. And in Python, you've got a couple of ways. Let's say that we wanted to do onboard LED. So onboard LED. That's hard to read. So you've got two different ways that you could write variables that have multiple names or multiple words in them. In Python, we usually use something called snake case, and it's where you use an underscore to separate words. In JavaScript, they like to use what they call camel case, which means that each word, usually you start with a lowercase letter, and then each new word gets an uppercase letter. So which do you think is easier to read? An uppercase letter or an underscore? For me, I believe that snake case with underscores easier to read, and it's also the standard that's usually followed in Python. So that's what I will be doing and what I recommend you do. There is no right or wrong, but whenever you're writing Python code, it's best to try to follow what most people do. Makes it easier for other programmers to read your code because it's what they're used to. In this case, we're just going to call it LED. So we have LED equals, and we're going to use capital P pin because this that we imported, this pin that we imported is capital P pin. It's actually a class. A class is just an object that tries to be like something that you are developing the code to represent. So they wrote a class called pen, and this pen acts like a pen on the board. So it has different things you can do with it. Now, we're going to be controlling not GP0 and not GP1. We're going to be controlling this LED. This is a special pin on the board here called capital L, capital E, capital D. And it's a string. So we have to give it a string called LED. And all of the other ones are integers. So if I wanted to control pin 0 right here, I would just write the number 0. But this LED is special. It is a string. So capital L, capital E, capital D, and end our quotation marks because it's a string. Now, we do a comma because we need to tell it whether it's an input or an output pin. And the way we do that is by using the pin class and then a dot and a special capital O, capital U, capital T. And we close it with the parentheses. Now, we're done. We've created a pin LED. Normally it would be 0 or 1 or 2 or 3. In this case it's special. It takes a string instead of an integer, and we tell it that is an output pin.out. Once we do that, we're going to hit enter. Now, just like we did with A, remember we typed A earlier and we saw that it was a string called hello world? Now we're going to type LED and see what it gives us. And it tells us that it's a pin, and it's actually GPIO 25, and its mode is output. We're flashing the LED, so we're doing output. That's exactly what we told it. We told it was LED. It knows that that's a special pin, and it's actually GPIO 25. Now that we have this, we can do LED, and we can do dot. And there's an autocomplete feature to Python, MicroPython in this Wokwi, where if we hit tab, it will show us all the different methods that we can call on this pin class. So this pin has different methods, and methods are just basically functions that you can call that do different things. And one of them is on. Whenever you call a method, this on, well, let's just do led.on and hit enter. And it gives us back that it is a bound method. But we didn't actually run it. We just asked it to tell us what that is, and it's a method. If we want to run this method, we have to put an open and a close parentheses on the back end. And then when we hit enter, it's going to tell the LED, which is pin GPIO 25, or in our case, we told it pin in all quotes, capital L, capital E, capital D, and it will tell it to turn on. And we just turned on the LED on our board. Again, if we want to see what we can do with it, we can do LED dot, hit tab, and then once we've done that, we can see that there is an off command or an off method. So we type dot off, open parentheses, close parentheses, and hit enter, and it'll turn it off. We can see here that we've got another one called toggle. And toggle just means whatever state it's in, whether it's on or it's off, it flips it to the other one. So if it's on and we hit toggle, it'll turn it off. If it's off and we hit toggle, it'll turn it on. So let's try toggling it. It was off, it turned on. Remember, I can hit up and I can cycle through all the previous commands that I did, but if I just hit up once, then it's led.toggle. So if I just hit up, enter, up, enter, up, enter, up, enter, up, enter, I can flash the LED on the board. All right, so now we're going to move over into this window here and we're going to write some code. So I'm going to just delete everything. And we're going to do the same things that we did over here in this IDE window. integrated development environment. So I'm going to do from machine import capital P pin. And then I'm going to create my variable LED. Remember, it could be anything I want. I'm going to use my pin class, and notice that it pulls up pin for me. And once I type the open parentheses, look what it does. It types the closing parentheses for me. That's very handy. That helps me not make a mistake and forget my closing parentheses. And this is one of the examples of what an integrated development environment does for you. It makes it easier for you to write code, making fewer mistakes. Now, my pin is a special pin that goes in quotation marks. It's a string called LED. As soon as I type the first quotation mark, look what it does. It adds the second one for me. Again, that's very handy and helpful so that I don't make a mistake and forget to close my quotation marks. So I'm going to do capital E, capital L, capital E, capital D, comma. I'm going to do pin. Now I typed capital P and it popped up pin, and I can just hit enter so it will auto-complete for me. I'm going to hit dot and capital O, capital U, capital T. And once I've done that, then I can do LED dot, let's do off first. Since mine is on, I'm going to go ahead and tell it to turn off. And then I'm going to restart my simulation, and it turns my LED off. Now I'm going to tell it to turn on and restart my simulation, and it turns on. So we can see this code is running, this code is working. If I wanted it to tell me what the state is of my LED, I can do print, and then I can do LED dot, I believe it's value. And let's try running that. I don't know if it's value. I think it's value. And it's probably running so fast that I'm not seeing the output. So I probably need to sleep. So I'm going to do from time import sleep. And I'm going to tell it to sleep for that 0.1 seconds that we saw earlier. So it has time to connect to the USB. And it's printing a bound method. So to get my value, I need my open and close parentheses. Because remember, we saw that earlier when I typed LED.on and didn't put it. There we go. So a 1 is on and a 0 is off. So that means let's try typing off and run it. And let's see if this turns to a 0. And sure enough, it's off and it printed a 0. This gives you a basic idea of how to run your code in the IDE, how to use the REPL to interact with the device, how to use an import statement, what an integer, what a string, what a float is, how to use the type command to actually see what type a variable is, what a variable is, how it is dynamic and it takes whatever type you put into that variable. In the next video, we are going to write a loop, and we're going to have our LED flash for us. And then we're going to start to develop from that to get a little bit more complex. So this hopefully was a good start for you. Play around with some of these things, try things. Notice that if it doesn't work, that's okay. You got to just look for the mistake, read your error codes, and ask for help if you can't figure it out. All right, see you in the next video.